Right, on the bench today, in amongst all the other junk, we've got a SBUS decoder. So what it consists of, we've got an Arduino Nano over here. I'm using a USB ASB programmer, which you don't have to do. You can use the usual serial port, but the SBUS signal is also a serial signal that's running into the serial port. So if you're not using a USB ASP, you have to remember to disconnect the SBUS signal every time you upload the program. So we've got a Nano, we've got an OLED display, which is optional, and we've got over here, this is an orange Spectrum compatible receiver, giving out an SBUS signal. It does 8 channels of SBUS, although the SBUS protocol does up to 16 channels. I'll come on to that. And I'm using an old Turnigy radio with an orange module in the back to transmit to that receiver. Now if I just zoom in a bit on the display, these OLED displays are they're very clear to the eye, but they're a bit tricky to get cameras to focus with sometimes. So if I move the sticks on the transmitter, I've set the OLED display to only update about 3 times a second to avoid flicker. You can see I'm moving channel 1 at the moment. The throttle, that's throttle low, I'm getting 150. The throttle high, 1901, that's channel 1. And then moving across, I'll put the throttle back to low, moving across the to the second position, that's aileron, moving the aileron stick, and then we've got elevator on channel 3. Channel 4 is rudder, first one on the second row, and then I've got some pots on channel. That's channel 5 on a pot, channel 6. Channel 7, channel 8 I've got on a 3 position switch, so that's low 150, middle 10, 20, 5, 6, and high is 1901. Now as I say, the SBUS protocol, actually it's a serial signal, and it runs at, if I can remember, it's 100 kilobaud. It runs at 100,000 baud, 8 data bits, parity, even parity, and 2 stop bits. And it's an inverted signal in that it's it's the opposite polarity to what the serial port would normally expect to receive. So if I just zoom out a bit, over here is a transistor that inverts the signal before running it into the serial port. And SBUS has got 25 bytes per frame. And at the moment, if you work it out at that baud rate and everything, each frame takes 3 milliseconds. But this particular orange receiver, as you can see at the top of the screen, it's sending a frame every 11 milliseconds. Now if I switch the transmitter off so that the receiver loses the signal, what this particular receiver does is it sends the frame lost and failsafe bits. It also does failsafe channel 1 to whatever it's remembered when you bound it in the normal spectrum or orange wave. So I'll put the transmitter back on. I've got a switch warning. Right, it's transmitting now, and if I put the throttle up high, that's 1901 throttle, switch the transmitter off, you'll see the signal drops to 150. That's just what the orange receiver does, and it only does it on channel 1. It doesn't remember failsafe values for the other channels. Back to the SBUS signal for a moment. You can see the SBUS protocol has 16 ordinary channels, and they're all 11-bit resolution. They go nominally 150 up to 1900 thereabouts. There are 2 digital channels on a real Futaba system. That's channels 17 and 18, which you can see is just displaying a 0 at the moment. With this orange receiver I can't show you those working because it's only 8 channel. And then there's the frame lost and failsafe bits. Right, if the signal, when there's no signal, you can see up at the top of the display there, we're getting 22 millisecond frames. That's just what this particular orange receiver does. So even when it loses the signal, you see the transmitter's back on now, we're getting 11 millisecond frames. When the signal's lost, it starts sending 22 millisecond frames, but it still keeps sending frames. If I actually disconnect this wire, I'll just zoom out of it and show you what I'm disconnecting. This white wire here is what takes the SBUS signal into the Arduino. I'm going to disconnect that now, and after 2 seconds we'll get a message saying that the signal's lost completely. And with this particular receiver, if I remove the power from the receiver and power it back up again, and I want to put the signal back into the Arduino now, this receiver doesn't send any frames at all until the first time it's acquired the signal from the transmitter. So if I it's not focusing very well, is it, at the moment? If I switch the transmitter on, come on, focus. If I switch the transmitter on now, as soon as it starts transmitting, we see all the frame data, and then, as I say, when we lose the signal, it doesn't go back to not sending any data at all. It just sends the most recent frame with the failsafe value, and it sends it every 22 milliseconds instead of every 11. Now, the main reason I've done this project is not actually for the display, and it works exactly the same if you disconnect the display. The main reason I've done it is to use it as a wireless buddy box. So if I just move the Arduino out of the shot at the moment, I'll just show you there. On D9, this orange wire here, it's outputting the first 8 channels of SBUS as a CPPM signal, which is what a buddy box uses. So if I've got that hooked up to my little buddy box CPPM display tester here, which I've now brought into the shot, and of course it doesn't want to focus on that either, which is an even smaller display. But you can see we're sending out a standard Futaba CPPM signal, which is standard buddy box, 22.5 millisecond frame with 9 pulses because it's 8 channels, and the low going pulses are 400 microseconds width. And if I move the throttle, you can see both on the numerically and on the display at the sort of oscilloscope type display at the bottom, you can see it's doing channel 1, and there isn't this 3 updates a second there. That's updating as often as the SBUS frames are received. So well, it's updating every 11 milliseconds, but the CPPM frames are every 22.5, so it's getting updated every 22.5 milliseconds. And that was channel 1, and channel 2 is the aileron, and channel 3 is elevator, 4 is I mean, on Futaba it would be normal Futaba order, but with this Spectrum type receiver, channel 4 is the channel 1's the throttle, 4's still the rudder. So that's about it. As I say, normally this is going to be used as a wireless buddy box, picking up an SBUS signal from a Futaba receiver and outputting it as a CPPM signal into a Futaba buddy box system. And the display was really just for testing, but as I say, if you leave the display unplugged, it still outputs the CPPM signal just the same. Sorry to have rambled on for so long, but thanks for watching.